Welcome back, Mathletes, to another episode of Math with Dr. Math, and we're just taking a little trip to Dr. Math Studios because today we're talking about logs. All right, Mathletes, so let's go ahead and talk about these logarithmic functions. So before we do that, let's hit rewind and let's talk about exponential functions so we could see the relationship between the two. Because who knows, they might be cousins.
Hola!
All right, so here we go. We have an exponential function, and we're going to be looking at our base, and our base is going to be greater than 0, and it can never be 1. All right. So when we look at the exponential functions that we were discussing last time, what we're going to see is that these exponential functions pass the horizontal line test. And what that's going to tell us is that they're one-to-one, and that is indicating that they have an inverse. There exists an inverse function, right? So since there's an inverse function, let's find it. All right, so here we go. F of x, let's just write that as y equals a to the power of x. So there's our exponential function, and let's find its inverse. So we know we're going to go ahead and change our x and y values, right? Because that's what we talked about when we talked about the inverse, finding the inverse. All right, so now we swap the x and y values, and now what we know is we're going to have to go and solve for y. All right, so this is where the problem begins, solving for y. Because notice y is an exponent, and I can't just divide by a, right? That doesn't make any sense at all. So we're stuck here, but thankfully we have a new function that's coming to the rescue, right? Which is our logarithmic function. And what I want you to really understand is that this logarithmic function, this is the inverse. All right, this is the inverse of an exponential function, because what I'm doing, what a log is, a log represents an exponent. A log is an exponent, right? So make sure you tell yourself that a log represents an exponent. That's what we're really trying to find, right? We're trying to find what is the value of this exponent right here, right? So by definition, whenever you see x equals a to the y, that's the same thing. That's the equivalent statement as saying y equals log, look at what our base is. Our base is a, log base a, and what does it equal? Well, in this case, it equals x. So these two statements are exactly the same. So right, this right here is our base, because as you know, it's all about that base, oh baby. All right, so this is the base, and we know that this right here, this y, we said it's a log, which represents our exponent, right? And we could see that that is our exponent. And what we're gonna have here, this is called our argument, but what I like to tell my students is this is what it equals. This is our answer. So I'll just say this is our answer. This is our argument here, our argument. All right. And so this is how we come up. This is how the idea of logs came up, right? Because we're trying to solve a lot of these problems where we get really close approximations, but we need to be exact. So thankfully, we have this log function. All right. So a couple of things to note, to jot down. We know that a is greater than 0. We know that a cannot be 1. But let's talk about x, because I know a lot of you guys are still wondering about your x.
Wow.
All right, some of you got teary-eyed there. So let's talk about x. Well, what I'm going to let you know is x has to be greater than 0. And let's just see, well, why is that? Well, you give me any value of a that fits this criteria, right? Where it's not equal to 1 and a is greater than 0. And what you're going to see is that you raise any positive number to any exponent. So let's pick one, right? Let's say we have a is 4, and then you raise it to, let's raise it to a negative number. What you're going to see is no matter what you choose, for that exponent, this is 1 over 16, that your result, right, is always going to be positive, right? The bigger or the more negative this exponent is, right, in this situation for a base of 4, you're going to see this is going to get smaller and smaller and smaller. It's going to get close to 0, but it's never actually going to be 0. So our argument, make sure you have this in your notes, is always greater than 0. So there's our foundation for logarithms. So remember, the log represents an exponent, right? If you forget that, boom, just get a tattoo, right? You'll never forget again. All right, so first important fact. Let's move on. All right, so let's make sure we got this foundation down. So what we're gonna do is something very important. We're gonna learn how to go from log form to exponential form and then vice versa, all right? But the key to really understanding this is make sure that you hit that subscribe button and like our video. Remember, share it with a friend or 10,000, right? Get the word out. We're trying to help people out. Don't be greedy, right? Share these videos. All right, so let's talk about log form here. So we have our log form just as we told you earlier. And what we're gonna see is that if you ever want to go from log form to exponential form, this is how we transition. So our base, right? It makes sense. That's our base. We said this is our exponent right here, right? So there's our exponent. So we color coded this so that you could easily change this into your notes, right? So you have some nice notes to hang onto your fridge, right? And our answer here, right? Our argument is right there. And what I like doing is I like drawing a little map. So let's say that we do have some logarithmic form, whatever it is. So what you're gonna see a lot of people use is they'll draw a little map. So let's say you start with the base and you raise it to this exponent and what that equals, and sometimes they'll do like two things here to represent like an equal sign, and that's gonna equal our answer, which is our argument. So we start with the base, there, raised to the exponent, and it's gonna equal our argument. So you start with the base, raise to the exponent, and it equals your argument. So just a little quick little map to help you go from one form to the other, because again, it's gonna be critical for us to be able to transition from exponential form to log form and vice versa, right? It's kind of like being bilingual. You're gonna see the benefits of this because there's some things in some languages, right, that it's really hard to express when you translate it to a new language, right? It doesn't have that same meaning and that same feeling. You're gonna see this happen when you have a form that might be in something that might be in logarithmic form, right? It might make much more sense if we were to translate it into exponential form first. All right, so again, with practice, you're gonna see all this play out. All right, so let's go ahead and let's do a quick little example before we get into the hardcore stuff, right? Because we're laying down that foundation. All right, so here's a reminder of logarithmic form. And here we have a logarithmic expression, and I want to evaluate this, right? So we have log base 3 of 9, log base 3 of 9, right? When you're reading it out loud. So if I were to remember correctly, right? If I use my little map, I have a raised to the power of y, a raised to the power of y, and what that's gonna equal, right? I'll do two little lines just to help me at first. That's gonna equal x. So here, I'm gonna use that same thing. So 3 raised to some power, 3 raised to what power is gonna equal, right? Is going to equal 9, because what we stated earlier is that this logarithm represents an exponent. So we're looking for the exponent. 3 raised to what exponent is gonna equal 9? And this is an easy case where now in exponential form here, in exponent form, what we're gonna see is, it's quite easy to see that 3 squared, right? So this question mark here has to equal 2. So the missing value, this equals 2. So you could easily see that this that was in logarithmic form is now in exponential form, and it makes this problem much easier to solve. All right, folks, so there's our quick little intro to logs. We have much more to talk about. So again, don't miss out. Subscribe, and we'll see you in that next video. Peace.